truth is finally here. Okay guys, we're going to take this polished metal knockdown and a dead blow hammer. We're going to push into the panel so we get an extra deep dent. Okay, push into the panel. Oh, that's a sharp pit. Lots of stretch metal on that one. Let's see that again in slow motion. Yeah, this will be fun. It'll make a good demonstration. Put a quarter next to it. Have something to reference. Obviously way bigger than a quarter. And we can put a golf ball next to it. Definitely bigger than a golf ball. The reflection doesn't even begin to straighten up around it. The problem is the depth here. Very deep. Alright, we've got another camera here set on the highest magnification, and you can see how the light disappears right at the pit. That is a deep dent. Okay, we're going to be doing this dent in just a moment, but first we have to go through a little bit of theory. Now don't skip this, this is important. Okay everybody, today we're going to be talking about sharply impacted dents, BB gun dents, high-speed rock chip dents, anything that has a very sharp point at the bottom with a whole lot of stretch metal on the side. And that's exactly what we have here. That purple line, that's your impact point. That is going to be massively stretched metal. That's going to be the problem child right there. The area in the green on either side, that's still stretched, not as bad as that. This area over here, pretty much normal metal from about there to there. Now the problem with this is we have a whole lot of stretched metal there to gather up in a very small area. And that's always our problem with something like this. So what we're going to do on this, instead of using a pencil tip like you saw in that other video, this one here is going to require a needle tip. And it's going to require more accuracy in that other one and more closely connected pushes. We're going to have to connect every push with the one before it. Otherwise this is not going to work out very well for us. So every push is going to have to be, I would say, thickness of a sheet of paper spaced between the one before it. That's going to take some decent tool control, but you can do that down a door or a hood with just a little bit of practice. And the needle tip will gather that stretched metal beautifully. And remember what we say, guys, stretched metal is thin metal only. If I'd hit that same force with a golf ball, no stretched metal, no thin metal whatsoever. But a metal knockdown will really stretch metal when it's hit that hard. Okay, the three tools we're using is this soft tip tool. We're only going to use that for a couple of tips, a couple of pushes max, just to raise the metal up. We're not going to push it at all into the surrounding panel. Now the pencil tip that we used before, no way is that going to make it. We have to go to our needle tip. Very sharp tool. That's the only tool that's going to get this job done. Okay, we're about ready to start. We have our soft tip tool in there. And we're going to put just a couple of very soft little pushes. Okay, we're going to start pushing with our soft tip. Got some of the depth out, none of the impact point out, of course, just a little bit of the depth. Okay, now any more than that, and we're going to start pushing that metal into the surrounding area. We got to stop it right there. Any more than that, and we're going to be in a lot of trouble. The rest of that metal is going to have to be gathered up, start to finish. Okay, we've got our starter board adjusted, and we've got our camera adjusted, I think, to where you can see it pretty well. Yeah, we're good to go. Alright, we're making short stroke, very connected pushes. Not enough to make outies, of course, just enough to gather metal up. We're coming close to making outies, but not quite. I'm sure we'll make a few before we're done here, but they won't be very bad. Main thing we're doing here, guys, is taking our time and again gathering little bits of metal up with that needle tip tool. Pencil tip would do some of that, but needle tip's going to do it a lot better. Okay, I'm sure some of my students watching this video are saying, Marty, I thought you told us whenever you use needle tips, you always use a heat gun. Well, you certainly do, and if this were a customer's car, I would definitely be using a heat gun on this. Problem is, if I had one out right over that dent, it would interfere with what you were seeing in the camera, and you wouldn't be able to see the detail that I wanted you to see. So yes, we do use heat on something like this. It would make the metal gather up a little bit better, get the paint more flexible, less likely to crack. We'll leave the heat on through about the first 95% of the repair. After that, we can take it off. And you'd want to use right around 160 degrees Fahrenheit since we're working on steel here. I'll show you the setup I use a little later for keeping heat on the dent while you're repairing it. Okay guys, like we've talked about, this is where the patience comes in. You getting bored yet? Well, we have about, I'd guess anywhere between 3 to 4 more minutes of this, maybe a little bit more. We're slowly gathering up metal at the bottom. And if you get in a hurry, this is where you're going to cost yourself tons of time on the back end. Nice and slow. We'll get there eventually. And guys, another thing to remember is the total area that I'm working with my tool tip is probably not going to be any more than about, at the most, the size of a BB. That's it. That's where my tool is going to stay throughout this entire repair. Like I said, connected pushes. You get paid for your patience and your knowledge, guys. Like I said, if you can do these, you'll pull in work from quite a distance because most techs wouldn't even consider doing something like this. Now, if we could have used heat on this repair, that would have been a little further along right now. Heat really is an amazing tool, guys. When I'm doing stretch dents and other complex stuff, odds are I'm using heat at least for a good part of the dent. At points like this, I really wish I could incorporate feeling into videos somehow. We're using much, much less pressure now than we did even a minute ago. And we've pretty much got this puppy licked now. And can you imagine, guys, doing something like probably the worst type of dent I did like this was 32 BB gun dents on a beautiful new Toyota pickup. Truck guy spent like $15,000 just for the paint apparently, and a bunch of vandals hit just the door only with 32 BB gun hits. It took me, I think, about 6.5 hours to do all 32. It was insane, and in fact, by the end of the day, couldn't even feel my wrists and my eyes were pretty much shot. But it's the kind of thing you'll get called on to do if you can do stuff like this. You got no one to say no to. I really should have said no on that one, but it turned out really, really well. Customer was ecstatic. Probably wouldn't have done it if he hadn't been a real loyal customer and sent me tons of work. And every one of those dents was pretty much like the one I'm doing here. Very, very impacted, very stretched, very sharp. And now you notice that fog is really squeezing up. We're right at the pit here again. We've been at the pit before, but we're there again. Just trying to get a little bit more stretched metal gathered up right at the bottom. Probably about the third time I've been at that exact center of that pit again. But we're getting really, really close. Okay, time for some tap down work. Couldn't get 100% of that metal gathered up at the pit or the impact point just yet. even though we did everything right. So we're going to knock the shoulders down from around that dent. And after we get the shoulders down, we're going to be putting a few more sharp pushes in the impact point. And as any experienced tech knows, being accurate with that tap down is every bit as important as being accurate with your tool. Tap downs very often is where you make most of your money on quite a few dents. Now the shoulders are forming pretty easy. That's because we still have just a titch of stretched metal left at that core. I'm doing a little bit of work around the perimeter first. And right back into that core. There we go. A little more tap down work. Got to get those shoulders down first, guys. You leave those shoulders there and try to pick up that core, nothing much is going to happen. Shoulders have to come down first. So whenever you make a shoulder, you stop doing your dent, get those shoulders down. There we go. Yeah, impact point right at the pit finally started to release. Okay, a little more shoulder work. Being very accurate here. Okay, about time for that starter board to go, and we're going to hook up our finishing reflection here. Give me just a minute. I want to see right in the bottom of that little tiny pit, and this reflection is going to help me do that. Okay, just working on that tiny bit of pit area, guys. Some of you may think I'm being a little bit too picky. We want to make this as nice as we can. It's always impressive when you get a really deep pitted dent like that and you make it look really pretty. Body shop manager or the high-end customer just loves you. They think you're a miracle worker. All you are is patient and accurate. And that's all it is, man. Being patient, being accurate. On these really deep ones, sometimes you have to go back and forth between your shoulders and your tap downs. Sometimes many times, depending on how deep that pit is. And every time you do, you gather up a little bit more metal. You don't want to be pushing against shoulders, though. Every time you form them, you need to be knocking them down. And this is real-time dent work. We're not stopping the camera a bunch of times and making things look better than what they really are. This is how long it actually takes. The only time I stop a camera or readjust is when I hit it with my face or something like that, because my face is so close to the camera. Okay, we're going to color sand this a bit. I generally do not like color sanding. I do it very, very seldom. But it can be a good way of bringing a borderline dent or one with a very, very deep pit like this to a little more acceptable repair level. Just be very, very careful. Don't take off too much clear. And it probably goes without saying that if you're doing this for a high-end car club guy, you better get his permission before color sanding. Actually, written permission is even better. Usually they will not want you to do that, but I've seen exceptions to that. And just a quick little hand buff here. And by the way, the cutting and polishing compound I like is 3M Finesse It. Does everything in one product. Meguiar's puts out a similar product and it's every bit as good. Okay, time to pan the dent. Nice thing about an overhead fluorescent reflection, it shows every nitpick and detail. And we don't want to hide anything. We see that the sharp spiked center there, just a little bit of something going on. But this is easily a 98% repair. We would never promise 100% on something like this, of course, because you couldn't deliver. There's just too much stretch metal at that bottom. But easily sellable. Okay, at this point that pit might be improved if we wanted to spend quite a bit more time on it, but I don't really see the point. We've clearly demonstrated what a needle tip can do, so hopefully you'll be encouraged to start practicing with one. Now, this is an example of a severely stretched dent at a tailgate. A customer backed into a 2-inch copper pipe at a construction site. Bent the body line, really stretched the metal badly. If you'd like to read the tech article I did on this repair, go to doording.com. Here's another view of that tailgate. You can see that metal is severely stretched, as we said. I did this demonstration for 2 students and decided to make a tech article out of it. This is the finished repair, done to better than a 95% level. Now this is just one example of what you can do with needle tips. It really does pay to learn how to use these guys and get very comfortable with them, because they'll allow you to do work that no other tool will do, especially when you don't have access to the back of the panel to use a hot box or a shrinking disc. Okay, here's the setup I use when I'm keeping heat on during a repair. Works very, very well. I use it constantly. Keeps the paint together, helps the needle tip to gather up a little bit more metal. And the heat should stay on the repair, usually to about the 95% level most of the time. And as always, if you learned something from this video, don't forget to like us and subscribe to the channel.